Okay, class 8. In the last video, we spoke about physical quantities. Okay, to give you a recap, physical quantities are things that can be measured, like, for example, length, mass, time, area, volume, speed, density, weight. Okay, and we had spoken about two physical quantities. We spoke about mass. All right, that is the quantity of atoms and molecules packed in a body, whose units are kilogram, gram, quintal, ton. Okay, volume, the amount of space occupied by a body. All right, whose unit was cubic meter, the SI unit, cubic centimeter, the CGS unit. All right, and we looked at the relation between a meter cube and a centimeter cube, or cubic meter and cubic centimeter. 1 meter cube is 1 with 6 zeros centimeter cube. All right, so today's video we are going to talk about density. This is another physical quantity. This is called density. Now it is defined, density is defined as the mass per unit volume of a substance. All right, now mass per unit volume of a substance, meaning you have a certain volume of a substance given. What is its mass? All right, okay, so that would be its density. Okay, so density is generally represented by, mathematically represented by, density is mass per unit volume. This statement is written in English. Okay, this actually is a mathematical statement. It is defined as mass per unit volume, mass per unit volume, mass per unit volume. Density is, this is how you write mathematically. Okay, so this density is the mass per unit volume of a substance. So if density is D, mass is M, volume is V. Okay, so density is mass divided by volume. All right, okay. Now see, so what is density? Now, to understand what density is, okay, see, I have taken to almost, although this is not exactly a cube, actually it's a cuboid. All right, this is a piece of wood that I've taken. Okay, let me call it a cube for now. So this is a cube. All right, now this is a cube of wood. Okay, now I have, although this is cubic, this is cylindrical. All right, but they have almost equal size, almost equal volume. These two things have almost equal volume. Okay, now what we see is this iron, this piece of iron, okay, is much heavy. Okay, it is much heavier compared to this piece of wood. Okay, now why is that so? Although the volume of both of these two things, one iron and one wood, both of these two things are almost the same. The volume is almost the same. Okay, but this is heavier than this piece of wood. Now why is that so? Because in this volume, okay, of iron, this volume of iron, more atoms and molecules are packed in this volume compared to this. Okay, almost equal volume, almost equal. Let us consider for now, they have the same volume. Okay, but compared to this piece of iron, lesser amount of mass is packed in this volume. Okay, whereas more in the same volume, more amount of mass is packed in case of iron. Okay, so although the volume of both the substances, we are taking it to be, although strictly not the same, we are taking it to be the same. Okay, we are saying it's the same. So although the volume is the same, the masses packed in both of these two substances are different. The masses packed in this volume of iron is more than the amount of mass packed in the same volume of wood. So therefore we say the density of iron is more than the density of wood. Remember that. Okay, so density basically means how much mass is packed in a certain volume. In case of iron, we see more mass is packed in the same volume as in case of this wood. Okay, the volume of the wood is the same, but lesser amount of mass is packed in case of wood. So therefore we say the density of iron is more than the density of wood. Okay, so that is what it means. That is what density means. Density means in a given volume, how much mass is packed. The more mass is packed, the more mass packed in a given volume, okay, the more will be the density of the substance. The lesser mass packed in a given volume, okay, the lesser will be the density of that substance. All right, now in the last video I had told you, in order to measure any physical quantity, any measurable quantity, okay, we need the help of a unit. The unit we use to measure density is kilogram per meter cube, which happens to be the SI unit, and gram per centimeter cube, which is the CGS unit. Now, you don't have to memorize how we get these units. Okay, it comes from the definition. Okay, density is mass upon volume. The SI unit of mass is kilogram, and the SI unit of volume is meter cube. So this is division sign. So this means density's unit is SI unit will be kilogram per meter cube, and that is exactly what we've written, kilogram per meter cube. Okay, the CGS unit of mass is gram, and the CGS unit of volume is centimeter cube. Okay, so therefore the CGS unit of density will be gram per centimeter cube. So that is exactly what I've written, gram per centimeter cube. Okay, if you know the physical quantities, the fundamental, most basic physical quantities, and you know their units, okay, you can easily get the units of higher physical quantities like density. Okay, all right. Now the next thing that we are going to talk about today is the relationship between kilogram per meter cube, that is the SI unit of density, and the CGS unit of density. It's very, very simple if you follow if you know what these things are correctly. Okay, so 1 kilogram per meter cube means 1 kilogram. This per is the division sign. So 1 kilogram divided by 1 meter cube. Okay, so 1 kilogram per meter cube means 1 meter cube. Okay, like I told in the last video also, in algebra you write x, which means 1x. So I write meter cube means 1 meter cube. Okay, so 1 kilogram per meter cube means 1 kilogram divided by 1 meter cube, or 1 kilogram per meter cube is 1 kilogram means 1000 grams. Okay, divided by 1 meter cube means 1 meter into 1 meter into 1 meter, which is equal to 1000 grams divided by 1 meter is 100 centimeters now, 100 centimeters. So instead of every 1 meter, I write 100 centimeters into 100 centimeters into 100 centimeters. So this gives me 1 kilogram per meter cube is 1000 grams divided by 1 with 6 zeros centimeter cube. From here, from here, you could have directly jumped to this expression over here. You could have directly jumped over here. Okay, because this relation, this denominator relation, we've already seen in the last video. 1 meter cube is 1 with 6 zeros centimeter cube. All right. Okay, so therefore we could have directly jumped over here. So 1 kilogram per meter cube means 3 zeros, they divide each other, and we are left with 1 upon 1000 gram per centimeter cube. So 1 kilogram per meter cube means 1 upon 1000 gram per centimeter cube, or 1 gram per centimeter cube is this 1000 multiplying here becomes 1000 kilogram per meter cube. Remember these relations, very, very important for you all. Okay, next, some points to remember. Okay, points to remember about density. One thing, okay, so I take this piece of paper, over here, all right, where I've written notes for class 12. Anyway, I go on changing the shape of this paper. Okay, this paper already had a certain density. This paper has a certain density. I go on folding it, that is, I go on changing its shape. Remember, when I change the shape and thereby the size of this piece of paper, remember its density is not changing. Okay, its density remains the same irrespective of the shape or size of this piece of paper. The density remains the same. So that is point number 1. Density of a substance does not change with the change in shape or size of a substance. All right, another thing, I can't show you this second point over here in the video. What you have to take my word for this. When we go on heating substances, like for example, I go on I heat this piece of iron. Okay, when we heat this, what happens is this piece of iron will go on expanding. Okay, so it expands, meaning its volume goes on increasing. Now let's come back to that mathematical expression for density. When the volume goes on increasing, when the denominator goes on increasing, mass remains the same. When we go on heating that piece of iron, remember its mass is not going to change, but its volume is increasing. When its volume increases, that is when the denominator increases, the density goes on decreasing. Remember that. So when we heat a substance, its volume increases, okay, and thereby its density decreases. Okay, generally, or most substances expand on heating. Not all substances, but most substances, okay, expand on heating. All right, so increasing its volume. So the density of a substance decreases when the substance is heated, or when we increase the temperature of the substance, the density of the substance decreases. Remember that. Okay, and one last thing. You get a question like this in class 8. You get a question like this: the density of brass is 8.4 grams per centimeter cube. Okay, what do you understand by the statement? This is a very, very simple statement actually. Okay, you have to understand density properly. So 8.4 gram per centimeter cube means that in 1 cubic centimeter, or in 1 centimeter cube volume of brass, its mass will be 8.4 grams. 1 centimeter cube is almost half the size of this wooden piece that I have. It's almost this size. Okay, all right, it's almost this size. So it means 1 cubic centimeter, if I have this big brass, its mass will be 8.4 grams. Okay, if I weigh it, its mass will be 8.4 grams. This is what the statement means. It means that 1 cubic centimeter volume of brass has mass 8.4 grams. Okay, if you have any confusions, any doubts, you can let me know. Okay, all right, you can check if you haven't checked my previous video, you can go through it. All right, only then after watch this video. Okay, any problems you have, you can always let me know. You can write it in the comment section down below. Okay, all right, so this much for now. Thank you.